My name is Sneha Narendran. I've been ThoughtWorks as a full stack developer for around 2 years now. So that's all about me. Suganya, would you like to go next?
Yeah. So I'm Suganya. I've been with ThoughtWorks for almost 3.5 years now, and I've been working as a full stack developer.
So before we get into the actual crux of the session, um, so let's lay some ground rules. Any thoughts, any questions, you can post it in the chat, on the Zoom chat. We would be answering either then and there, or we would be having a separate Q&A session. Not just for questions, any thoughts or experiences are also welcomed on the chat. We will be only covering the key concepts, and we're not going, it's not an in-depth session per se. So that's a point to note. Please try to make it as possible as an interactive session through the chat. There would be a 15-minute break in between. And also a feedback form will be shared soon. And your feedback is very valuable to us. So please make it a point to share the feedback. The session is already being recorded, and let us know in case of any discrepancies, like you're not able to view the screen or if you're not audible, we'll try to fix it. So with that, let's start. Let me share my screen.
So I'll post a feedback link there in the chat so that you can check whether you're able to access and all and keep. Yes. Let's start with system design 101s. Like as the name implies, it is a 101, right? We are going to only talk about the key concepts that you need to know in order to approach any kind of system design problem. And we are not going to touch, we are not going to go in depth, because that is going to be a huge session and it would become tiresome, right? So that's where we want to only give introduction on all the key concepts before we actually take a interactive problem, which is a photo sharing app designing. Okay. Okay, before that, could you post in the chat, like what is the system? What do you think is the definition of the system? You can post anything, like whatever you comes into your mind.
Let's make it an interactive session. There is no right and wrong.
Yeah, and we are not going to judge you and all. Like you can share anything which you think. Okay. So software, okay. It solves a particular problem. Good. Anything else? The place where your application runs, process input to give output, independent units, group of items that work together to solve a problem. Okay. Okay. So if you Google the system definition, right, it is like a group of items that work together to solve a problem, or it's like a independent units come together to complete a task. Then you can call it as a system. Okay. So let's have this key thought, anchor thought, and then now let's proceed with the next slides. Okay, so today's agenda would be, we would be discussing what is the system design, what is how the high performance system design will look like, and what are the key characteristics of the high performance system. And these are the main three concepts, which is load balancing, caching, and partitioning. Okay, and the second half of the thing would be designing an actual photo sharing application, which would be an interactive session, which will have a lot of activities. Okay. Now, since you have also said, like, what is the system? What is system design? System design is like designing a system in a way that it serves the requests at scale by efficiently handling the different infrastructure components and their interaction. So that is the definition, right? Like when you consider a system, or you might be building a website. So if you take that, right, it will have many infrastructure components. Like you will be having an application server, you will be having a database, and you will be having web servers and a lot of things, right? These are called infrastructure components, and there has to be some kind of interactions between them in order to serve the requests, serve the usage, right? So that is like a system definition, but you need to efficiently handle the different infrastructure components. That is the key point there, key point here. Yeah. Yes. So when you are considering a system at scale, right? So what are the three things which has to be in your mind, right? Which is, what are the different infrastructure components that can be used? Because there are many kind of infrastructure components, but for your use case, what are the infrastructure components you need, that you need to know, and how these infrastructure components will work with each other, that also we need to know. And how do we best utilize these components? Assume you have a budget so much, and you want to increase the performance. So if you increase the SQL server's capacity, like a CPU, memory, and all that, you would end up spending a lot of money, but you would be achieving some kind of efficiency there. But then if you follow, if you efficiently use the existing component itself, you would be able to achieve the same performance using the existing component itself without having to spend so much budget, right? So that's where you have to best utilize the components. Yeah. Now let's, okay. In the chat I've got, can you brief more about the second point, which is how do how do these infrastructure components work with each other? It's like, if you have an application server and database and all that, these things should work with each other, right? Like if assume you are placing these infrastructure components in the different regions far away. So in that case, the network latency would increase. And it would essentially slow down your system. So that's where you need to work on the things like the interaction between the infrastructure components also. Okay, that way you can reduce the throughput, you can reduce the network latency and all that stuff. Okay, now let's move on to the key characteristics of the system design. Okay, so these are like a top 5 things which you need to keep in mind when you are designing a scalable system. Okay, so first thing is like a high performance system. So first thing is a scalability. Scalability is like an ability of the system to serve more and more requests, increasing demand, increasing network traffic, and etc. So for example, if your system is working perfectly fine when there are 10 users and it crashes when there are millions of users, then it is not a good scalable system, right? So that's where the scalability is an important aspect. And you can see here, we have two kinds of scaling, which is vertical scaling and horizontal scaling. Vertical scaling is like, you would be adding more capacity to the existing server. Like if you take a SQL server, you would be adding more DTUs, more CPU, memory, and you might be also increasing the tier to achieve more of this capacity. But it would also involve the downtime, right? Because switching from one tier to another tier would involve some downtime, and you would have only certain capacity, a certain budget. So you have those kind of limitations there. The second thing is the horizontal scaling. So where you would have the advantage of adding more and more servers to the same cluster. Okay, so that way you can add n number of servers to the same cluster and achieve the scalability. So when there are only 10 users, you can choose to have only one server. And it's a peak time and millions of users are hitting your system, then you can choose to auto scale, so that many n number of servers will be added to your cluster. Okay, this is the first characteristic. And second one would be the reliability. Reliability is like even if some of the software components goes down, if your system is still able to support you and able to serve the requests well, then you can say that system is reliable. Like for example, if you take a supermarket, right, and in during the COVID times, every employee will not be working in the supermarkets, right? So even with less number of employees, if they are able to serve all the customers, then you can see that supermarket is reliable, right? So that is reliability. Availability is like if your system is available, like available 99% of the time, it's like a period of, in a period of time, how much your system is available for to serve the user requests. So that is availability. And the next thing is the efficiency. Efficiency is like what is the throughput, like if a system is giving some response, like responding in less than millisecond when there are only 10 users, but it is not it is taking a lot of response time when there are millions of users, then you can call your system as not efficient, right? So if it is same whether it is 10 users or million users, if the throughput time is same, the response time is same, then you can call your system is efficient. Next thing is like manageability. So manageability is like even if some of your system software components goes down, if you're able to quickly fix that and able to bring that system up, so then you can say your system is manageable and serviceable. uh, Other things you can do is like if your system is able to alert you, like even before the failure happens, then you can say, okay, this system is going to fail and I got alert, so you will go and fix that even before the system is going to fail. So that case also you are increasing the availability because you have the manageability is in picture. So these are considered to be like a key characteristics of any high performance system. Okay, you have to consider all these points. Okay, now let's move on to this load balancing. Okay, so have you maybe can you post it in the chat what you think load balancing is? It may not have to be a software development definition. You can say any definition. Like, what do you think a load balancing is? Could you post it in the chat? Like, you can post anything. No harm. Distribute the load between different servers, controlling the traffic, share the load among different machines when multiple requests. Okay, delegating the pressure, pass the load equally to so that system is in balance. Yes, so I think almost everyone have given right answer. So it is like an ability, like if when you in a distributed system, when you have multiple, like Sneha, you can move on to the next slide. Like here definition is like load balancer reduces individual server load and prevents any one server becoming a single point of failure, thus improving the overall application availability and responsiveness. Like here, you can see there are multiple servers in a distributed system and load balancers sit in before that. So this would take care of handling, sending the routing the traffic to the different servers. Okay, if like whatever is available server, then it would traffic the request to that available server. So that's how the load balancer makes it work. So typically the load balancer sits between the client and the application server. And load balancer also keeps track of the traffic, means how the requests are received and how the response is being handled, so that in case if some server is not responding or it is having a higher error rate, it would skip that server. It will not send the future requests to that server, and also it will alert the users users in the sense like the system admins to fix that server. So that's the load balancer usage. Okay, typically to achieve maximum scalability, right, you can put load balancer in multiple layers. Okay, so whenever there is a distributed system and you have multiple servers, then you can put load balancer before that. Okay. Can you move on to the next slide, Sneha? Yeah. So what are the different layers in which you can put the load balancer? So you can put the load balancer between the user and the web browser. And you can also put the load balancer between the web server and an internal platform layer. And you can also put between the internal layer and the database. Okay. Let's see this in an illustration. Can you, yeah, here you can see there is a load balancer, right, which sits between the client and the web server. And there is one more load balancer which sits between the web server and application server. And here a load balancer sits between the application server and the database server. Okay, so that's how, like, if you want to attain maximum scalability and maximum availability, then you can put multiple load balances as and when required. Okay, now let's talk about. Can you move on to the next slide, Sneha? Yeah. So let's take a case. Okay, in a supermarket, you have purchased and you have added all the items in your cart, and you are trying to find one counter. There are many counters. You are trying to find one counter. Okay, so what would be the strategies you will be thinking of? Like, you might be choosing choosing a counter which has less number of people, right? So that is like a one way. And another thing is, like, you can check, like, even if number of people in one particular counter is huge, but only the people have very less number of items in their cart, then you will also choose that counter, right? That billing counter. And third scenario would be like, even if there are multiple people, if the cashier is swift and she is able to turn out more customers out of that billing counter, then you will also choose that one, right? This is like a different kind of strategies you would think in your mind while choosing a different counters while doing the supermarket or any kind of purchase, right? When there is a counter. So similarly, load balance, just putting the load balancer between all the servers, right? It is not going to work. You need to tell the load balancer how to route this traffic to the servers behind. So that's where different load balancing algorithms comes into picture. Okay. Any doubt here? You can post it in the chat. Okay. What is the difference between user and the web browser? Okay. So I think user is the one who will be using the system, right? And through the web browser only, we would be able to hit, if it is a website, you would be using the web browser to hit the system behind. Like, you would be accessing, if it is you are a user, like Sam Rubin is an user, and you would be using a Chrome web browser in order to access an Instagram page or a YouTube page, right? So that's the web browser. Yep. So let's.
Just a moment. I think Sam raised his hand.
Okay.
No, Suganya, it was about the previous slide where you have mentioned we can have a load balancer between user and web browser. The slide before this one.
Yeah, can you go back to that slide, Sneha?
Yeah, it should not be a user and web browser, right? We cannot have a load balancer between a user and a web browser.
Mm-hmm.
So it should have been web
it's
server,
like between
I guess.
A client and client and the web server. Yeah. So text mistake.
Understood that. Yeah.
Okay, now let's we will discuss about the top load balancing algorithms. We will not discuss about everything. So first one is round robin. In here, you would be having a list of servers, okay, and you need to the load balancer just cycles through the list of web servers and assigns the requests one to the next server. When it reaches the end of the list, then it would again start from the web server 1. Here you can see the first request is going to web server 1, 2 is going to web server 2, 3 is going to web server 3, then 4, 5, 6, 7, 8, all that in the sequence, in the same order. Okay, so this round robin you would be using when you have a equal capacity for all the web servers, like it is having same RAM, same CPU and all that stuff. Then you would be going with this round robin. And also if there is no persistent connection, if the connection is not going to take so much time and going to stay there for a longer period of time, then also you would choose round robin. Okay, but the important point here is if the web servers are not having the same capacity, assume one web server is having a lot of RAM and CPU and another one is having very less, then it would be the server with the less capacity also would be getting the same number of requests, then it will be bombarded and then it will go down, right? Because it will not be able to handle all the requests, so it might go down. So that is the main disadvantage of the round robin. Now let's move on to the next one. So this is like a weighted round robin. So here, based on the capacity of the server, you would be assigning some integer value to it. Like here in server one is, assume it is a high performing server. So you would be assigning, you have assigned the weight as 4, whereas the server 2 has a less capacity. So you are assigned the weight as, weight as 2 for the previous one and the weight is 4. So when the request comes, right, the first 4 requests goes to server 1 and 5th and 6th request goes to server 2. So this is just an illustration. This weight can be anything. Like you can come up with this integer number like based upon the use case and the problem you are trying to solve. Basically, you are assigning some weight, and based on that, the load balancer would give more priority to that server than the other ones. Okay. Now let's talk about the most widely used one, which is like least connection method. In this method, the server would direct the traffic to the server with the fewest active connections. Okay, so it will keep track of the active connections in each of the server and assigns the traffic accordingly. Here you can see you have 4 servers, right? For the 49, 50, 51 are initial connections. So the first request comes and it sees the server 1 has only 49 connections. So the first request goes to server 1. Now it will become 50. Okay. Now the second request comes, the server 2 and server 1 is having same number of connections, 50 and 50, right? So in that case, the round robin would be used. So the request would go to server 2. Now it has become 51. Okay. So now the next request comes, server 1 is still at 50. Okay. So the request will be going to the server 1. Now everything like server 1, server 2 and server 3 is at 51. Okay, active connection is at 51. So the next request comes, since server 3 has not got any connections, and since it uses a round robin, the next request would go to server 3. Yeah, now I think you would have got the point, right? Like how this works. Based on the connection, it chooses a server, and if 2 different servers has the same number of connections, it does the round robin between those servers to choose one. Yeah, this is the least connection method. Okay, now let's move on to the next one. Okay, this is least response time. This takes 2 parameters into account, which is what is the active connection, and also what is the response time. Here, here the response time is represented as time to first byte, and active connection is represented as active transaction. Okay, so first you can see the TTFB is 2 for the server 4, and active transaction is 0. So the first 3 requests goes to the server 4. Now the active transaction would become 3 here, right? So TTFB is time to first byte. Like it's like a so whenever you are measuring what is the response time of the system, right? There is some bit of time a server takes in order to warm up and bring up that system. Okay, so whenever you hit that server, during that period, it would take some extra time. So that's where like we would be only checking what is the time to first byte. Okay, so this server 4 has taken only less, responded quickly, like it brought up the server and responded quickly. So that's where the TTFB is 2. The server 2 has having higher TTFB because it has taken some time to bring up the server and serve the first request. So where are we? Yeah. So here the active connection would have been 3. So TTFB is 2. So the fourth request will be going to TTFB 2 and active transaction 2. Okay. Now this active transaction would be becoming 3. Okay. Now since it has become 3 and this is also 3, so the next request would be going to server 4. Okay. Now you have TTFB as 2 and active transaction has grown to 3 in server 1 and server 4. Now the sixth request would go to server 2. Yeah. Now you got the idea, right? It uses both the active transaction as well as this TTFB to decide which server the request has to be routed to. Okay. So that is the least response time. Even though the name suggests it's least response time, it takes 2 parameters into consideration. Yeah. Yes, let's move on to the next slide. Okay, benefits of load balancing. So if you have the supermarket example in your mind, right, you will be able to relate to all the benefits much easier. So user experience faster uninterrupted service, and users won't have to wait for single struggling server to finish its previous tasks. For example, you don't have to wait for a single counter, right? If the cashier is not swift and she's struggling to finish all the previous customer billing, you don't have to wait for that counter. So the next one is service providers experience less downtime and higher throughput. Yeah, because you are not relying on one single server. There are many different servers, so the throughput would be, and higher throughput means the servers in that cluster would be having only minimum number of requests assigned to that particular server, right? Because the number of requests is getting split between the number of available servers, so the throughput would be higher. The third point is like decreases the wait time for the user. Yes, when you have multiple counters, then obviously you can get your billing done faster. Helps to detect the traffic bottlenecks before it happens. Yeah, as I said before, load balancer also keeps track of all the incoming and the outgoing request and response, so that in case something is going to fail, it has an ability to alert, intimate before it happens. Yeah. Any questions on the load balancing so far? Kavita has asked a minimum number of requests can be taken by one server. This is with respect to which method, or could you ask this question again?
Like my question was, like a server can be taken by how many requests? Is there can be a fixed number of requests, or
it's more dynamic in nature, right? It's based on the capacity of the server, and it's based on the response time of the server. Like if the server has good capacity and it is able to respond to the requests much faster, it can take up more and more requests. There is no fixed amount of requests, minimum number of requests, or the fixed number of requests a server can handle. And since this is a distributed system, you will be having n number of servers, right? So you can't really limit or come up with that number. What is the minimum number or a fixed number?
okay. And my another question was, for example, now we have a server 1 to server 4, right? What if for example, and for server 1 of the request was came due to some technical issue, it got stuck, so it was not unable to take the next request. Similarly happened to the server 2. So similarly, like it happens for all the servers. Now the new request came, so what happens to the new request?
Okay, so you're saying the server 1 is it has received the request and it has failed. Okay, so in that case, user would obviously, because that's a request already went to that server, the user would obviously read 500 like internal server error, some kind of that, and the next request will not go to that server because it has already, it's failing. Like if it is a functional failure and if it is continuously failing, then load balancer will take care of that scenario. It will not send the future request to that server. Now the next thing is, like you are saying, every server in the, like all the server in the load balancer is failing. If there is something like that, it will not be instantaneous, right? There will be some amount of time before the server goes to a failure state. So load balance has that ability to detect the failure before it happens if you have configured that way. So you would be intimate if the server 2 is going to fail, it would be intimated and you can go and fix the server 2. So that way, not all the servers is going to fail at the same time. You will have some servers in picture to serve the requests.
Okay, thank you.
Okay. Now, okay. The other question is like, what are the different tools or texts that can be used for load balancing? How to deploy load balancer? Where we can find resources that we can use for our apps. So basically, we are having this multiple providers, right? The Azure, GCP, AWS, and all these stuff. These things by default they have something called load balancer. Okay, you can use that infra component and you can configure it there. So that is one way. The other way is like the Nginx also, Nginx, which can also can act as a load balancer. Okay, so or it can be a plain simple server which can receive all the requests and you can write some logic there in that server, and it based on that logic it would route the traffic to the different servers behind it. So there are different tools and means different tools that are available for you to implement load balancing. Mostly you would be using the providers, right, on most of the projects, so it comes out of the box. Okay, now let's move on to the caching. So could you post in the chat like what do you mean by caching and what do you think caching is? You can put anything in the chat. Streaming of data packets. Okay. Storing the most frequently used data. Okay. Anything else? Storing frequently accessed data in an intermediate layer for fast response. Yes. Uninterrupted streaming, storing data for easier access. Yes, all of this, right? Like, yeah, you have given right answer. Storing frequently accessed data and all that is correct. So now let's move on to the actual definition. Okay, yeah. So it's like a short-term memory. It has a limited amount of space, but is typically faster than the original data source and contains the most recently accessed items. Okay, but there are ways to tweak it. Like it cannot be a short-term memory. You can have things in it to be stored for a longer time, and you can do a lot of customizations around it. But this is like a default definition with the what cache has. Okay, now take this example. The client sends the first request. So, and what it does, it goes to the caching server. The response, the asset would not be there in the caching server, right? Because this is the first request. So it would directly go to the origin server and it would fetch the asset from there. Once the asset is fetched, it would be written into the caching server and the response is being written to the client. For the subsequent requests, you can see the client is directly sending the request to the caching server. Since there is an asset which is already being cached, it would return the response from there itself. So by this, you are cutting down a lot of different layers behind the caching server, and the response time is typically faster and faster. Yeah, that's what we are like achieving with the caching. While load balancer helps you to horizontally scale, caching will help you to efficiently use the existing infrastructure component itself. Like if you want to efficiently use the existing thing, then you can implement cache there. Yeah. Now let's move on to the next one. Like we will, the main problem with the caching is like you need to have the permanent storage and the cache to be in sync, right? It has to be coherent. So that's the main problem the caching mechanism comes with. So there are different schemes in which you will be writing it to the cache. Okay, so we will see what are the different schemes. Okay, first one is the writing through cache, which is in which data is directly written to the cache, like it is written to the cache and also to the corresponding database simultaneously, because since you are writing to the cache and as well as to the database simultaneously, it will be always data will be consistent between both the cache and the storage, right? But the problem would be every time you are writing into the cache and the database at the same time, it would increase some time because you are writing in two different spaces, so it would increase the time. So that is the thing here. But you will always have the asset or the data available in the cache while you are reading the data back. Okay, so that is the writing through cache. Now let's see the next one. This is write around cache. Okay, so this is like a most commonly used, even in the projects I have worked on. I have used this technique. So here you will be directly writing the data to the database, like the permanent storage. You will not be writing it to the cache. Okay, so while reading, it would first hit the cache and it will be treated as a cache miss because the data is not there. So now it would go and fetch it from the database, and while fetching back, it would write it to the cache data as well, and it would return the response. Now when the application queries it again, then it would fetch the data from the cache. Okay, it will be, because it is now the cache will be there, so it will be read from that cache. Okay, so the advantage of this method is like you will not have to flood the cache with all the write operations. Sometimes you will be not, you don't want to, like, you, if you have a minimum space for the cache system and you don't want to bombard it with all the data because you're not going to access them frequently, then in that case you can go to this method, write around cache. Okay, let's move on to the next one. Okay, write back cache. Here the data is first written to the cache alone. Okay, and on the completion, and the completion is immediately confirmed to the client. In the sense, the response will be 200. Like as soon as it's written to the cache server, it is going to respond to the client with 200. And the write to the permanent storage is done only after certain conditions, after certain intervals, with some certain conditions. Okay, in this, if your system is very write intensive, then you can get a higher throughput because you're going to just return to the cache and going to return the response. So there you can achieve higher throughput. But the main problem is if something happens or something goes wrong with the cache server, right? Then you would face the problem because that is like only source of truth and database will not have all the data. So that is like a problem with this approach, but mostly used for the write intensive applications and where you want to achieve higher throughput. Yeah. Now let's move on to the cache eviction policies. So now, since we have discussed that this cache server is going to have only less memory, like you can configure that how much memory you want to use for that, but then you don't want to keep all the data or the keys there forever, right? Because that then it would become like a permanent storage, and the volume of data in the cache server would increase. So that we don't want to do because we are having this cache for the faster retrieval and all that. So in that case, we have to evict the data in the cache. Okay, so there are different policies. Okay, more than this also, like I've only listed on top 5. So last in first out, which is I think LIFO and FIFO, I think everyone might have heard about. because this is stock and queue, right? You might have heard about it. Next one is LRU, which is least recently used. So here, when particular data is least recently used, then you would be clearing that. And the next one is MRU, most recently used. You might think, why do you want to clear something which is most recently used, right? Because you then it's defeating the purpose of the cache and all. But there are some use cases for this as well. Like assume, for example, you are getting this Stack Overflow. Whenever you are creating some account in the Stack Overflow, right, you would be getting some unique ID as an user ID. Okay, so every time it is a random alphanumeric string you would be getting as an user ID. So as soon as someone takes up that ID, someone takes up that alphanumeric string as a user ID, you don't want to use it for the other users, right? So in that case, what you would do, there will be some kind of key generation service behind, which can generate 1 million random keys like this, random alphanumeric characters like this, and keeps there. Okay. Now, as soon as the user logs in and creates the account, the key is being assigned to that particular user. So you want to clear out the most recently used one there, right? So that is the use case for the most recently used. And the last one is least frequently used. That is like if the item is not very frequently used number of times. If it is not used so many number of times, then you would be clearing it. So these are like top 5 cache eviction policies. Yeah. Any questions here? You can put it in the chat, like if you have any questions related to the caching. Okay, I'll take it as a no. And let's move on to the next thing, which is data partitioning. It is basically how the cache is cleared. Yes, 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 yes. Okay. In some instances, you might want to clear the entire thing in the cache as well. That is also still possible. When you want to clear everything from the cache server and you want to store it from the start. So that is also possible. Data. So let's move on to the data partitioning. Yeah. Can you post your, can you go back? Yeah. Let's post it in chat. Like, what do you think data partitioning is? Yeah, I think the data partitioning word itself has the definition, right? To know data partitioning, which is that we are going to cover. Okay, let's move on. Okay, can you go back one slide? I think you are
Sorry.
going forward.
Yeah, sorry. Sorry for that. Please continue.
Sure, no problem. Yeah. So data partitioning is a technique to break the bigger database into the smaller parts, and it is the process of splitting the DB or a table across multiple machines to improve the manageability, availability, and performance. And obviously load balancing, because you are going to split into multiple servers. So since we are saying you can split the table as well as the database. Okay. If the table is huge and it is going to be used often, okay, so in that case you would be splitting the table. If you feel like you are having a product, you have designed a product for a school, okay, so this product will be used by different school, right? Assume you have functionalities like taking attendance, and entering marks for the students for the assessment and all that stuff. So in that case, you might want to put each of the school into separate databases, so that it would increase the performance, and also yeah, it would increase the performance basically, right? Like, so that's the splitting a DB example. Yeah. Now let's move on to the next slide. So there are different data partitioning methods. So we'll talk about that. Can you go to the next one? Yeah. So there is something called horizontal partitioning, and there is something called vertical partitioning. Okay. So horizontal partitioning is also called as sharding. So here, what you would be you would be choosing one partition key. Okay. And based on that, you would be splitting the table or the database. So here in the example, you can see we are choosing the ID as the partition key, and based on that, we are splitting one large table into two different tables. So first one is having only 1 and 2, and second one is having only 3 and 4. So that way you are splitting the table. So now when you want to query something with which has ID 1, then it goes to that table 1. If you're writing a query with school ID 4, then it goes to the second table. Okay, that's how the query works. Yeah, the advantages, the benefits of horizontal partitioning, it is straightforward to implement, because you just have to come up with the partition key applicable for your use case, so that and it is very straightforward to implement. The disadvantages is like you have uneven distribution of data, right? So we were discussing about this school product. Okay, a school product where you want to assume you are creating a database for school 1. You are storing school 1's data into database 1 and school's 2 data in database 2. Okay, now school 1 can be a kindergarten. It might have only 20 or 50 people, students in that school. But if the second school is large, like it has so many number of students, then your data is not even, like one database is going to have less load and other database is going to have more storage, right? So that's the disadvantage of the horizontal partitioning. So now let's go to the next one. Vertical partitioning. Okay, so vertical partitioning is also called as a normalization. Here we would partition the data vertically based on the columns. Here in this example, you are having a user data, okay, and you would be using the username and profile data very often. So you want to split that into a separate table, and connections and content author is like a very rarely used values, right? So you in that case, you want to put them in a separate table. So that's how the vertical partitioning works. And let's go to the next slide. We'll see what are the benefits. Yeah, we can handle the critical part of the data differently from the not so crucial part, right? So with whatever examples we have took, the user data, the username, email ID, those kind of things will be those kind of things would be like can be maintained in a separate table, and not so frequently used, not so crucial part can be in the different table. So that's one key advantage. And yeah, the second point is almost the same, like we can separate the slow moving data from the most dynamic data. And disadvantage of the vertical partitioning is, like, since you are splitting it across multiple tables, whenever you are performing a query to fetch some data, the operational complexity of the system would increase because it is spread across multiple tables, this same data. Yeah. And yeah, the next point is, can you put, yeah, next point is, like, whenever there is an additional growth, it might need further partition, like it might need further partition. So that is like you will keep on looking for parameters to split, but columns to split. So that is like one kind of vertical partitioning disadvantage. Now let's go to the next one. What is slow moving data? Okay, slow moving data is like, for example, I think we will get an actual example while we are designing the photo sharing app. But then here, you will not be accessing the if you go back one slide, Sneha, here the connections and content authored is not so fast moving. Like we will not be fetching it often. Or you can say Twitter ID or a LinkedIn ID. So those kind of things of the user will not be fetching so often. So it's a slow moving data. It's kind of slow moving data. And username, email is like a fast moving because they are like you will be fetching it and using it often. Yeah, let's move. Let's go forward. Okay, let's talk about different data partitioning strategies. Okay. So we will take this case of the school product itself, okay, and we will discuss this different cases. There are different partitioning schemes, but we would only talk about top two, which is range partitioning. Here, maps the data to the various partitions based on the range of values of the partition key. Here in this example, you can see the first 1 to 1000 schools with IDs 1 to 1000 sits in the first database, 1001 to 2000 goes to second database, 2001 to 3000 goes to the third database. Okay, now it's simply straightforward. Like when the school ID is 2300, we know that it is going to be there in the data is going to be there in the database 3. So you can resolve it very easily. Okay, but the disadvantages is like uneven data again. Like the schools in the first partition, which is 1 to 1000, might be having less amount of data. So I assume only it has only 2 GB of data, or maybe 10 GB of data. But 1001 to 2000, those schools are very huge schools, and this database is like 100 GB of size. Okay, then it's not a good partition, right? Because the load or the query performance when you're hitting the database 2 is going to be really less. So that's where that is the disadvantage of the range partitioning, because there is no, you can't control it. Basically, that's the disadvantage. Now let's move on to the next one. List partitioning. In the list partitioning, each partition is defined and selected based on the list of values on the column rather than the set of contiguous range of values. Here, you can apply some logic here. Like you can say, to evenly split the load, you can come up with some logic. Okay, I want the school 1, 7 and 9 should go to the database 2, 2, 5, 6 and 10 should go to the database 1, so that you can somehow manage the data, the storage capacity or the storage in each of these databases. So that is that advantage you are getting with the list partitioning than the range partitioning. There was a question: what if one record is deleted in one range, for example 1 2000, can a new record be inserted in the range 1 to no, since it is a range, right? And the range is based on the partition key. So you have by record, what do you mean? Like a new partition key itself, is it?
No, so we were talking about different partitions like 1 to 1000, 1001 to 2000. And in that, if a particular record is deleted, Suganya, we might
like
we might end up having an unused space there, right? So we cannot be inserting a new record in there because that has a range of 1 to 1000. So in that case, we will be left with a lot of unused space in that approach of data partitioning. Is my understanding right, Suganya?
So we are talking about the range partitioning, right?
Yes.
And you are talking about something is deleted.
Yes.
Okay. So yeah, there will be like it is going to not unused space. The storage space is going to get calculated based on what amount of data you have in the database, right? So So in that case, you're saying if something is deleted, yes, obviously the GBs are going to reduce. GBs are going to be like, it's going to reduce only. So that is correct. And another thing I was saying is, even though like this is, since this is a range, we will not know like what is going to go into that database, right? A school can have varied number of students and records, and one school data might be huge and another school data might be very less, but we will not know which ID is going to have huge number of data and which ID is going to have less number of data. So if you use range, we don't have any control over it.
Okay, so this is not an indication of the record that is inserted, it is just an indication of your database storage 1 to 1000, 1001 to 2000.
Yes, that is like a school ID. Assume this is, we are talking about the school case, right? It is take this as a school ID. Okay. It is
Got it.
School 1. Yeah, it's a school ID.
Thank you, Suganya.
Okay, now let's move on to the last slide of the first part, which is problem solved by the data partitioning. Okay, so the database operations become faster. Yes, obviously, because we are splitting the data to a different database. The database operations are going to become much faster and prevents the network bandwidth starts reaching the saturation level. So which is like when you have huge volume of data, in order to import and export or whatever you do with that database, you would be requiring a lot of network bandwidth, right? So it might reach even the saturation level. So that problem is solved by the data partitioning. The third thing is like when you put all the 3000 schools data in one single database, that and more schools are going to get added to the same database, right? In that case, at some point of time, you would run out of the disk space. So that problem is also solved by if you use the data partitioning. And the next one is increasing the query performance. Yes. So if you are having a database which is going to have only few school records, obviously the query performance will increase because you just have to look through limited less number of records than the former case. Okay, and improve security. How security comes into picture is like since you are splitting the data to multiple different databases, you are obviously putting some kind of segregation there, right? So that's where the security comes into picture. So it's more secure than the putting everything in the same database or in the same table and all that. I think we are done with the first half of the session. Any questions so far? So we would be taking a 15 minutes break, and the second part would be the actual activity of designing the photo sharing app. So feel free to post any questions in the chat for the first session. So the first part is like really important, like because in your real project or real project, right, when you have a different use case every time, so you have to have an good amount of understanding of different algorithms, different strategies, schemes, so that you would be able to choose one which fits better for your use case rather than sticking into the one because it is one size never fits for all, right? Okay, Sneha has shared the mural link in the chat. You can access it and you can also join. Let us know if you face any issues there, because second half depends on it. Any other questions, you can put it in the chat. We will take care of it. And I'll also, since other people have also joined, I'll also post the feedback link in the chat. You can also add your feedbacks there. Then okay, now it's 11:04. Can we all meet at 11:20? Yeah, let's meet at 11:20 and we'll continue the rest of the session. Thank you. Not able to access the feedback link. Okay, I'll check about it. Is everyone back? Sneha, it's 11:21. Can we start?
Sure, then. Let's get it started. So I hope you all had a good break. So the next session for around like 1 hour or 1+ hours, what we're going to have is to imbibe the learnings what we had from Suganya session and to design a photo sharing app like Instagram. All right. So I feel that system design is an evolutionary process, right? There are no right and wrongs. It's like you learn from one mistake and go further. This whatever we're going to build, it's like Instagram. We are trying a very minimalistic approach with few assumptions beforehand itself. We are not diving in very deep on this, but do feel free to call out if you have any ideas or any questions on the chat group. And also please feel free to answer if there are any. All right, with that, let me share my screen. I hope everyone is able to access the mural as well. Please call out in the chat if you're not able to access mural also. All right. So other thing what you'll need apart from the mural is like a pen, paper, calculator maybe. There are few little tiny calculations we're going to do. Not um, very tiring calculations, but like very small brain tickling calculations here. So the agenda for this session would be to understand the functional and non-functional requirements of a photo sharing app. What are the different considerations we can take and what will be the database we can choose, and other things what Suganya mentioned, right? Like reliability, data sharding, and cache. How do you go about in a real-time system? So Instagram, I'll just make photo sharing app and Instagram very. Is my voice fine now? All right. Okay, we'll get it started again. So I'll be using interchanging the words Instagram and photo sharing app very anonymously. I'm not sure, like I believe everyone is like not new to the social networking service Instagram, where you can upload photos, share photos or videos, right? And you can also share it to, you can choose to share it publicly or privately. People can, I think, share, I can comment, like, etc., etc. There's so many functionalities of that social networking service. So the objective of this session would be to have a simpler version of Instagram where users can share the photos and others can follow. And obviously a news feed that we get on the Instagram. All right. Okay. Let us brainstorm. So whenever we start designing an app, right, we first need to know what are the requirements of it, right? So first we'll try to gather all the requirements. There are two types of it, functional and non-functional, right? Functional means on a quantitative basis. It defines what your system needs to do exactly, or to, what your system needs to accomplish. For example, for Twitter, it would be like the user should be able to tweet, or the user should be able to reshare. Okay, things like that. So similarly, for Instagram, what we're going to do, we are going to collect our functional and non-functional requirements. Non-functional requirements would be on a qualitative base. Like, let's say my system should always be available to the user. It should have lesser downtimes, on the quality base. So these are the two types of requirements we are going to gather now. Okay, let's jump onto the mural. I hope everyone has the mural link. Not, let me share again. All right. So people who are new to Mural, this is just like a board which we're going to use to capture your ideas into it. So how do I create, like for this activity, what will we be doing is, let's say functional requirements. Just grab a sticky note. You can grab it from here as well. Text, select any color you want, make it a bit smaller so that you give space for everyone, right? And just type in whatever you feel like is functional requirement. So let me start. Let's say like a photo. Okay, that's like a functional requirement, right? And just fill in this grid, functional and non-functional requirements. We'll set the timer to around 5 minutes, right? Uh, so yeah. Please also fill in the non-functional requirements. And there is no problem. If you want me to increase the time as well, I could increase the time as well. Ranjana, are you able to access the mirror board? Can you tell me the error, what are we getting? All right. If you are finding it too difficult to post it on the mirror board, please use the chat itself. Mhm. We'll be going through all the sticky notes you have posted. There is less than 15 seconds now. Let me know if you want me to extend the time as well. One thing I see is like there is no differentiation between the non-functional and functional stickies. It would be good if people could pull the non-functional stickies down a bit. Yeah, time's up. Does anyone need extra time? Is anyone still working on the board? Maybe I could wait for a few more seconds. Yeah, I think some people are typing and things like that. All right, let's start. Please feel free to add in your points. I might not be able to cover them, but let's see. All right, let's go from functional requirements. So as I said, functional requirements are more like what you exactly want the system to do, right? I started with the like a photo. Then we have search, follow, comment, upload a photo, suggest photos infinitely, trending photos, upload finding patterns, dislikes of a user. Yeah. Comment, reply to comment. All right. Create a user. Yes. We need to first create a profile before using Instagram. Upload a user profile and edit bio for personal account. Yes. Search. Yeah. I think this is not completed. Not sure. Share the photos is what I assume. Oh, share the story. I'm not sure. Yeah. User creation management, something we've already talked about, and share a photo. Yeah, all the CRUD operations like uploading, deleting the photos. Follow the user. Yes, that is something which we'll be talking about. Then reels. Yeah, that's something which has come up recently, and going live. All right. Yeah. This again with the creating user and creating a user profile and things like that. Get a shareable link for post. Yes, again, sharing a photo, profile page setup, set visibility and privacy settings. Yes, again, something related to profile, profile management, adding effects, transitions, filtering the photo, putting the photo or the image in the Instagram. Can someone elaborate on this? Not sure if I got it. We'll move on. Infinite scrolling, reacting of a like or a comment on the post must be instant. All right. Okay. All right. I think I did cover everything. But yeah, these are the functional requirements, which I mean, we see in our Instagram currently, or if even if we are going to create the new Instagram, we would be giving the use of these all functionalities. I think there was mute and unmute the video as well. All right. Did I miss anything? Anyone else wants to add any points on this? All right. We'll jump to the non-functional part. All right. Traffic. Yeah, we should be able to handle traffic. Yes, very important. The accessibility of the app. If your app is not accessible or user friendly, they won't be getting much traction there. So yeah, accessibility. Real-time updates, I think I'm not sure where to put it in, but I think it's a functional requirement. But yeah, people can correct me if I'm wrong. Performance, and I again get something called accessibility. Security, that is very important. DR strategy for failover. All right. What is the DR strategy? Anyone who put this sticky?
Yeah, I put this sticky. So basically, it's more about ensuring that your application is available, even if, let's say, some servers which are distributed across different locations, right? One place goes down, or there's some kind of a natural calamity or a flood or a tornado, and then that server is not available. So we should have active servers up and running so that we can redirect the traffic to those other servers. So something like that's what I meant by a disaster recovery, basically.
Disaster. Okay, sure. Thanks for that. Then yeah, something we learned from few minutes ago, caching. It should be responsive, yes. Then response time should be less. Yeah, there should be lesser and lesser latency. Imagine you scroll through a news feed and the photos are not coming up, right? It doesn't give a good user experience. It should be scalable. That's true. If you have 20 users now and you want to scale up to, let's say, 1 million users tomorrow, it should be able to do it, able to handle traffic. Yes. Low latency, able to see comments near the rate, like in real time. Highly available, highly horizontally scalable. All right, available, ease of UI UX. Okay. Recent news stop on feed. I think I'll push this into more on functional requirement. If that suits better, but people can challenge and pour in your thoughts as well. Available, offline support. Okay. Authentication and authorization, something again with the security and things like that. Versioning. Okay. Could someone share their thoughts on why they put versioning in non-functional requirements?
Yeah, I have added this sticky. So maybe different versions should be there. Like something is failed in current version, then they should be able to shift to another one.
Regular
is-
updates.
Yeah, regular updates. Kind of.
All right. Okay. Fault tolerant, yes. And yeah, we catch about security. Is there anything I've missed? Any sticky I've missed? Yeah. Did I read this? High traffic management, load balancing. Yeah. Yeah. So yeah, well done, people. This is something which we'll be looking for as requirements, right? Having an early set of understanding the requirements in an early stage helps us to understand what do we exactly want with the system to do, and thus helps us designing a system. Though we have all the answers and many functional and non-functional requirements, right? We'll be only covering few. In functional requirements, we'll be covering that users will be able to upload, download, share the photos and newsfeed. And in the non-functional requirements, I would be highlighting that it should be highly available. Like many people said, yes, you don't want your system to go down again and again. Latency, when you're trying to scroll through your newsfeed, some kind of latency is always there. I mean, it shows a loading button for around 200. Let's say latency is expected for around 200 milliseconds. Let's say that it should be highly reliable, right? So these will be the major key takeaways from this. Let's go back to the slide. And yeah, I think that's it. And also it should be highly reliable. If I didn't mention that before, let's say I upload a photo today and tomorrow it goes missing from my profile, it would be a very, very, very bad user experience, right? So reliability is also something we'll have to take care when we are designing an app like Instagram. All right, a photo which I upload should never get lost. We'll descope all the tagging, commenting, things like that, and we'll just focus on the crux of whatever I've mentioned. All right, let's move into the design considerations. Okay, so let's say I upload a photo, right, today, and I have 200 followers. Now, what I understand is my 200 followers are going to look at this photo. I write once, but I'm sharing it with 200 followers, and it's like going to be a read heavy system. So we can conclude that our system is going to be a read heavy system, and there is no limitation on any number of photos that I can upload. So we'll also need an efficient management of storage. As I told, low latency is expectable, but like not a very high level of latency. As I suggested, 200 milliseconds of latency and all is expectable, but not much greater than that. And then it should be like 100% reliable, as I told you. Let's say I upload a photo today and tomorrow it's not there. It's not a good experience for me. So these are the few design consideration. I'll stop here. Let me know if we want to add few more here on the chat itself. If not, I'll move on. All right. Okay, let me move on. So as of today, I got this statistics from a website. I'll be sharing the link to that as well. The actual numbers are like something like this. Today, Instagram monthly active users around 1 billion globally. All right. And daily active users around 5 billion globally. So that's the range of users we're going to deal with when we are creating something called like Instagram. Also, people spend an average time of 29 minutes on the app. And there is a geographically, some countries or some states geographically use Instagram more than others, right? That is also something you have to consider. And also, some trivia is like around 95 million Instagram users could be even fake. So these are like the actual numbers. What we are going to assume is we have only 500 million users, that is around 50 crores. Our daily number of active users are going to be around 1 million, that is 10 lakhs. Number of photos uploaded every day is going to be around 2 million, and average photo size is going to be around 200 KB. Now there could be questions around resolution and things like that also coming up. But let's de-scope that for a moment. And I would like you all to make a note of this assumption for the forthcoming calculations. I can post this on the chat as well. All right. So these are the assumptions we're going to build something with. All right. So let's calculate the capacity that we would be needing. All right. So when I say every day, they're going to be 2 million photos uploaded, right? I would be able to conclude that per second, I would be having 23 photos. All right. How I got this number is 2 million divided by the number of 24 into 60 into 60 number of seconds a day. That is, I'll get around 23.14. So I got this number. And for 1 day of photos, I will be having to have a space around. I said that 200 KB is the space that I need for one photo. So 2 million photos into 400 KB would be around 400 GB. Now I would like you all to calculate me the space for 10 years. So I have given you the space that would be needed in for 1 day. What would be the space for 10 years? And if possible, please do also convert it into TB. Let's take 2 minutes and post it in the chat. And please do mention also if you're not understanding or following this. Yeah. Around 1025 KB, TB. Yeah. Yeah. 1460 TB. That's the answer I got. Around one. Yeah. Yeah. Thanks for this. Yeah, it's around 1460 TB that we're going to get. So as I've got the answers, I'll just move on. All right. So what we have in a very high level, right? This design is going to evolve slowly. But what do we have? We'll have a system, all right, which is by which we are going to have two operations basically. One to upload an image, one to view or search an image, correct? And then we will have an obviously a image storage, something like an object storage, right? And we'll also have to store some image metadata. Okay. Object storage, just diverting a bit, is something for an unstructured data that offers limitless scale. You could explore on that more, but this is a very high level diagram of what we have. We are going to evolve on this diagram, all right, through many other considerations which we're going to have in the future. So basically this is it. In a nutshell, you need something to upload, view and search. You'll have a database to do and fetch and write to, all right. So that brings us to the next activity, database schema. So I am assuming that everyone here has designed at least one table in their college, right? So what do we have in this activity? I'm summoning everyone to this database schema. So what we will do in this activity is we'll try to figure out what all tables do we need to design this application. Okay, again, there are no rights and wrongs. All right. It is a very good practice to define the DB schema as early as possible. So even in the future, if you want to data partition, we'll know the schema and we'll know the points where we can partition also. Okay. So just for example, I'll start with one. This is not the exact answer, but let's say I need a person table. Okay, I need you to write what all attributes that it would need. Let's say name, and it would be a varchar. Let's say an ID, it would be an int. Okay, I hope you got what we are trying to achieve here. So the name of the table and the attributes and what data type it would be. All right, we'll take around 10 minutes for this. All right, let's get started. I've increased the area of the area, the content. You can also try posting things down so that you don't merge with other answers. We have less than a minute left to fill in the mural. Please let us know if you need extra time. Yeah, time's up. Let's quickly go through the mural. Okay, we'll start from top left. We have something related to the archive. All right, which is story ID varchar. Okay, we have some event ID varchar timestamp, post type, photo. Okay, it's kind of an enum, which we have. All right, image table, size, ID, image type. Then we have a user table. I see user table lot many places, but it would have, yes, user ID, varchar, name, details. What kind of details is the question, right? It would be helpful if we could elaborate on that details more. Image ID, okay. Photo video details. Again, I'm not sure if video details needs to be in the user table. But yeah, that's a good try. Obviously, we need to link between one post and the user. We have image again, ID, size, date uploaded, date modified. Date modified. Date uploaded, date modified. The question we need to ask ourselves is, should yeah, I mean, this is right. Date modified of the image, date uploaded, comments, right? Comments behind each image. Can we like model that better? And person ID or user ID, whichever person has uploaded it. All right. User, profile, post number, followers number. Okay. I think I did read that. Saved post. Okay. User ID, list of post IDs, list of post IDs. Not sure about this one. Comment, text, varchar, yes, int ID. User profile, name, photo, username, bio, website. All right. Then story, again something like post, I believe, which has an ID, created time, liked by, followers. Okay, followers, I'm not sure if a story has followers or user has followers. Maybe that level of domain understanding we can have here, right? Again, person or a user has ID, name, varchar, followers, following, bio, number of posts. Okay, on the comments, yeah, ID, user ID, story ID, date change created is detailed. I mean, people are also, you're free feel to ask doubts if you see anything different in others' sticky notes. Would help us understand better on maybe, if it was like a good thinking, you can appreciate it, or something you feel it's not right in the specific table, you can call out that also. User, again, user ID, name, email, post, video streaming table, maintaining 10 seconds of video. Okay, this is a very, very important implementation detail which we have here now. Maintaining chunks of 10 seconds of video in particular users. User ID, story ID, video URL for S3. That's good. User ID created by, timestamp, uploaded by. Okay, the user and the. Wait a minute. Why do we need uploaded by in user stories? Okay, this is like posts. Okay, uploaded by. Okay. Followers, we have something. ID, number, varchar, profile photo. Yeah, profile photo is something which I didn't see earlier. Username. I have image again, ID big int. Are we okay, where binary image? Okay. Metadata. Yeah, that's something also we'll have to consider. User ID, photo. I'm just seeing now for if there is anything different, all right, because I see most of the points covered in the earlier photos. There's something called reach in percentage. Content type, reach in percentage. This is something not seen. Can anybody elaborate on that?
Hi. Actually, I had added that. The thing is, whenever there is this statistic graph that sometimes some influencers use to understand how much reach has that particular post or photo has reached. So usually it's denoted in a graph way or a percentage sort of way. So to understand how many users it has reached in a particular day or within 24 hours. So for that reason, I had wanted to use that. I don't know exactly what is the name, but usually we denote it in percentage. So that's why I had used float.
All right. That's a good, I mean, good thought process. I think I did get your idea. But maybe what we can ponder on more is, do we store the percentage or do we calculate this percentage based on some metrics on the fly? Maybe to show in a dashboard, we like calculate it because it's ever changing, right? Maybe the metrics I am having today might not be the metrics I'm having tomorrow. So do we do something that, do we store some kind of metrics first and calculate percentage on the fly and show it on the front end, or do something, or maybe store percentage itself? That's something we can think about, which is not in scope of this talk, but something we can think about. But thank you for that. Reactions also something I have not seen in the early things, but yeah, most of the people covered whatever I wanted to think about, and not maybe something which I have not also thought about in their cards. But is there anything specific um, that we want or I missed? All right, I'll take that as a no. But yeah, what I have in my, let's for calculations which are going to come up in the further session, I have photo table, oops, and I have a user table. I mean, this does not invalidate anything which is above. Like to have a common calculation, right? I'm just putting it forward. I have a photo table and a user table, and also a user follow table, because that was the scope which we started from, right? Our photo will have, let me change the color. Let's start with ID, which is an int. User ID, which is also an int. Photo path, like I saw some S3 buckets and things like that. Obviously, no, it won't be a bear cat. All right. I could also talk about the place where the photo was taken, right? So I would might include photo latitude, which is again an int, and longitude. And creation date, right? Things like that, which is your date time. All right. Similarly for users, let's duplicate this. I could have an ID. I could have to link between. I've already put user ID to link between photos and user. Then I can have whatever we just put, right? Name, email. It can have plethora of details, date of birth, for the profile creation, whatever we thought about, create like profile created date, right? And last login. which could be used in some kind of statistics. And user follows, we have, I mean, 2 people follow, right? So we'll have 2, I think I saw user follows somewhere. Yeah. So we'll have user follows, one user ID, and the follower ID, whoever we are following, right? So this would be the base database, but good job, people. I think we covered mostly whatever you want on the table front in this exercise. So let me share a poll with you next. I'll stop the share for a moment. But I hope everyone in this call are aware of SQL and NoSQL, right? So if we have a large amount of relations in our database, we usually go with a SQL database. But if you want to scale our database for a higher level, now we have very recently started using NoSQL databases for unstructured data, right? SQL includes like MySQL, Oracle, MSQL, Postgre, things like that. NoSQL is like Cassandra, MongoDB, or things like that. Okay, so many examples more. There's also something called GraphDB. Okay, so I'm gonna launch a poll. Let's see if I can do that. Yeah. I hope a poll should be able to is appearing on your screen now. Which type of database do you feel is the best suited for a NoSQL, I mean, photo sharing app? We'll also discuss why we chose that answer. I may end this in 1 minute. Maybe you can parallelly think about it, search on the net on what are the differences maybe, and get to this question. Okay. I see more 10 people are supposed to answer the poll. I'll end it in a few seconds then. So the things we need to consider while even deciding if we want to go with the SQL or NoSQL. Oh, sorry, there's a typo I just realized now on NoSQL. But yeah, NoSQL is the type of data structure we have, right? If it's structured, non-structured, do we want to scale it even more, right? Do we have like a, do we want to scale it more? Or do we have many relations in the database, right? We could also have a combination of SQL and NoSQL databases for various other purposes. All right, I'll end the quiz, end the poll now for now. I'll share the results. Hope the results are on your screen. Very, very close, right? We have 53% with NoSQL and 47% with SQL. So as I told, this is also a very important decision we should be able to take whether we want a SQL database or a NoSQL database. This is going to impact us in many ways in the future if we do not select a database which is for our data, for our usage, right? We can also, now let's talk about photos in general. There are going to be a huge amount of photos we are going to receive both globally, right? As we just discussed, we'll have around 2 million photos which are uploaded daily. All right, around 20 lakh photos which are uploaded daily. So not all databases would be able to accommodate that, or it won't be an efficient way to accommodate everything in a particular database. So we might have to stretch a bit and use services like S3, which I think I saw in one of the video link for S3, something like that, or go forward and use something like HDFS or something like that. Maybe people in the, I'll just give it a moment. If people in the team have any experience with using S3 for storing photos or HDFS for sharing photos, you can maybe pitch in and let the group know. All right. All right. With that, we'll come to the last part of our calculation activity, which we're going to do. All right. In this activity, what we're going to do is to calculate how much data would we be storing in each row. All right. So the main reason I wanted you to write down what data type your attribute would be is for this exercise. All right. So let's say for this photo table, I'll consider my int to be 4 bytes and date time to be also 4 bytes. All right. So I'm saying for storing int, I need 4 bytes. For user ID, which is again an int, I'll need 4 bytes. For photo path, which is a varchar, it could go up to 256 characters. So I'll say 256 bytes. These are all 444, right? Ouch. 4, 4, and 4. So totally, how much do we get? 4, 8, 8 plus. So we just want to calculate just by adding how much data would each row take in. So around, I think 275 bytes just to store one row of photo table. Sorry, was my calculation? 485 bytes of photo. I missed this. I worked on an Apple project where they are storing installer files in S3 bucket. Big installer files are 500 MB. Akshay, would you like to, I'll just stop this activity for a bit. Would you like to elaborate on that experience more? Was there any challenges or what were your learnings, things like that?
Yeah, sure, Rosna. So Apple is actually, I mean, they are storing the installer files. So for downloading any sort of installing anything on your mobile apps, so they are giving the S3 link. Okay, I mean for the user, if that user has proper authentication and if he has paid for that installer file, so there is a S3 access URL gets generated for every access token, and that would be I mean that installer file will be picked from the S3, and so there is a limit in the S3, I guess some 500 GB or something which we can store it big files with the size of 500 GB. So but we had file sizes of from ranging from 500 MB to 1 GB only. So that's why we have used the S3 bucket, and yeah, that sort of experience which I think I have
Thanks for sharing, Akshay.
Sure.
Sorry, I didn't see the chat before, but yeah, thanks for sharing that.
Sure.
So similarly, for user also, there should be some, this is around 285 bytes for one row of data. All right. And for similarly, for user table, we'll have some amount of, let's say 68 bytes of data. All right. Now, I'm not doing the calculation because of interest of time. We have so much more to cover. But
Sneha,
yeah, sure.
sorry to interrupt, but I had a question. So are we assuming that the actual file, the photo itself, is stored in S3 bucket and we are just storing the path of that S3 bucket location?
Yeah, yeah,
Okay.
yeah. Sorry, I didn't catch the team. Who was that?
Javeria here.
All right.
Thanks.
Yeah, thank you. So as I was saying, so imagine we'll have 500 million users. That's what we said in the first set of activity, right? We'll have 500 million users. All right. And this into 500 million bytes, right? So that is the amount of data we're going to store. Similarly, if I say this is around 285 bytes, that's what it came about to. That into 2 million, right? It would be around I think 0.5 gigabytes or something. That's the amount of storage you would need to store such things. Okay, and calculate that for around 10 years. I mean, if you're scaling your app and you want it to be alive for around 10 years, it would be a lot, right? So this is some capacity estimations you could do in your free time, but I will pass this for now. All right. So let's have a quick recap on whatever we discussed till now. We had an introduction to Instagram, wherein we said that this is the Instagram, and we scrutinized all our requirements together in our functional and non-functional requirements. We also discussed on some, what are the design considerations that we would be needing. We started with some assumptions for this. We did have some capacity estimation calculations, which we had. We looked at this high-level system design. Then we had a wonderful time designing the exact table, what we would need. And I think I should really appreciate you for all the sticky notes and ideas you put in through. We also started, we had a poll to discuss what database do we even select for this, right? For that. And this is some calculation that I leave you to as homework, if I may, right? That you can calculate for how, like, what would be the space that would be required for the database you have written on the mural for 10 years, right? So yeah, I'll take a 2-minute break for letting you seep in everything, maybe 1 minute, because this is like a huge session this is going on. After this, we'll have mostly theoretical parts, but obviously some questions also. But yeah, I'll just pause for 1 minute per se. Okay, let's start. Let's continue some more time. Just hold on for some more time for this. Next, we have some more brain tickling activity. All right. Now I am giving you a problem statement. Let's think. All right. We have seen this component design earlier, right? Which we have an upload image. We'll have to search for an image. We have a storage and some metadata, right? Now, just expanding on that idea more. All right. We'll have photo uploads, all right, can be slower, all right, whereas our reads have to be faster, especially if they're being served from the cache. As our first design consideration was that our system is read heavy, all right. That is the first thing. Now, I think there was one question when Suganya was even asking taking one of the load balancing things that, let's say I am doing all the right operations, all right, but the system is getting with all busy with our read operations, right? and I have only limited number of connections that are possible. Let's say 500 connections at a time. All right. And cannot have more than 500 concurrent uploads and downloads at the same time. Your system is there. You have a limited number of connections. All right. And you're not able to do it all together concurrently. This would hog the system, right? So what can be an improvement in the database that would reduce this concurrency or this latency while you know, while designing it? Please do also let me know if the question was not clear. In a nutshell, you have only these many number of connections. You can't do both reads and write at the same time. All right, that would totally hog your system. What do we do? All right, there's a ask to repeat the question. Yeah, and I also see answers as well. Writes can be asynchronous. Maybe I can repeat the question once more. So there is a system. I'll just. All right, we have a system here, right? I'm having 500 users trying to upload the image at the same time. Also, I'm also having 500 users trying to search that image on the same time. But one limitation that we would be having is on the number of requests the server can even take to take in parallel, right? What can I improve in this design that I don't have to worry about that database connections are like limited, right? I mean, the server can only have 500 connections for at the same time. What can I do to improve this design? Yeah, I get something like first try to cache, and from this, right, caching and write back cache. All right. All right. Thank you for the answers. As I said, there can be a plethora of ways you can design the system. All right. It may not be one solution. We'll just discuss about one solution that we have in time. What we can do is we can, instead of having a bottleneck here on the database side of things, one way is to separate uploads and downloads, right? If I do that, only my upload request will go to this at the one time, and my reading request will go to this at the one time. So yeah, Aditya is also mentioning create read replica and redirect that request to that replica. Yes, that can also be done. But when you create replicas, right, there is one issue of synchronizing them, right? You would need to make the original source of truth and your replicas to be same. That is one problem backend developers usually have. But if you're able to solve it, that will also be a good good solution. So this is one way that we can deal with that problem. Going forward, something Suganya touched upon was reliability. Okay, and how do we make sure our system is reliable? One popular way of making the system reliable is to have redundancy. That is, store the copies of photos even replicate the servers or the databases so that there is no one point of failure even when your system fails. So our component design would look something like this. I have replicated the service also and also the image storages and the image metadata. So even when one fails, you will have a replication in process. So it's never lost in such, okay? But again, when you create replicas, you have to make sure that they are in sync. Next, we move on to data sharding. All right, there is something more to think about, right? We saw many things like range based list, data sharding and things like that. um, what is the main point of sharding is that sharding key, that is, on what basis will you even shard that data? All right, so we have our user table, our photo table, and things like that. On what basis will you actually shard the your whole database? Let's think for a moment and let me know the answers on the chat. I'll give you some example on this. Okay. Maybe if I choose to shard based on geographical location of the user. Yeah, I think Shubham has already said that on user regions. So if I do that, let's say I'm saying the North America region is one region of my shard. Let's say the Southeast Asian part is one region. All right, I can divide my shards based on that age group of the users. Okay. But I was just continuing to say, whenever we try to choose the partition key, we need to make sure that the data will be equally distributed. Now, let's say I choose my sharding strategy as a geographical sharding, and let's say I'm sharding based on countries. I say India, and I say some other country like which doesn't use Instagram at all. Okay, some country X. Okay, now India will have a lot of data, and that country X will not have like large amount of data. Now my all requests are coming to that one shard, India shard, right? And it's going to be a lot of requests. And again, we'll come back to square one when we are not able to, it's not efficient. If I have all the requests to one database, it's going to hog the system again. All right. Now coming to age group, let's see the advantages and disadvantages of age group. I think it would be easier to have shards based on age groups. Let's say, I think let's take the example that only 15 years and above will be able to use this app, right? So 15 to 18, 19 to 21. Sorry, 21 will be too much. 19 to 24, 24 to 30 are three shards that we have created. After 30, right? 30 to 50, let's say that age group wouldn't have much, how do I put it? Much traction there. Or I'm not sure if the users who are between 30 to 50 age group use Instagram or will use their app too much. So all that traffic would be directed towards that 19 to 24 age group who are, I think so, who are using Instagram a lot. All right. So there are advantages with that data partition and disadvantages too. But thanks for the answers. Those things were in my mind. Anyone else would like to give a shot? Experience of all the employees. Could you elaborate on that, Kavita? Yeah, please go ahead.
Yeah, like I was thinking about the resume, like for partitioning the like some companies will be like they will be say, right, the qualification or the experience of the candidate should be 3 years, 3 years or more than 3 years, like that. I'm not sure. I was just guessing that.
Thanks for answering, but I'm not sure if and there is no employees in the picture, right? There are just users like us who are going to use are going to upload the photos and things like that. But let's put that in the parking lot and let's see other answers. We have range of dates uploaded. All right. If I have a certain month, let's say I'm dividing the I'm having, let's say a month has 30 days, right? And I'm having charts for 1 to 5, 5 to 10, 10 to 15, so on and so forth. Yeah, even that could be, I think, a good way to shard. But this would need a lot of user data, user usage data, because we don't know which day of month they would be using the app too much. But yeah, that could be a possible solution, Deepika. Shubham Pandey, not sure if this was covered by user regions, sharding, help in fast networking and latency. Shubham, can you elaborate on that more? How would it help in fast networking or latency?
I mean, as in, if we are using cloud services, cloud also will have some servers, right? So it will be like India. Let's say India has some servers, so
Mm.
it will be less latency region, right? If we have
All right.
sharding on the regions.
All right. So we are talking about CDN here, if I'm not wrong, right?
I guess yes. Yeah.
Yeah. So CDN, yeah, CDN could be a possible solution, but we're thinking on how we can shard or divide the whole data into regions, right? I think we'll cover CDN in few minutes. Shubham, thank you for that answer. Akshay says based on the number of followers of the user. Akshay, what do you feel? I would like you to answer this. Let's say I have 200 users following, and you have like 1 million user followings. Okay, that is again an unequally distributed uh, thing, right?
Yeah, what my thinking was, like, people who are having lot of millions of followers, they those users will be less. Okay, so
Okay.
maybe we could go with the range sort of thing, that we if we were able to find out the people who have more than 1 million users, we will have a segregate. We can segregate them, or who have only very less number of users, and then there is a middle range, then that middle range we could do some sort of ranging. I mean, we could bring more ranges in between. That was my thinking process. Maybe I'm wrong. Yeah.
Okay. Let's think through this, right? So Akshay, you have around 1 million users. Okay. I'll take Javaria as the next example. She also has 2 million users. I put you both in one shard. Okay. Now I have 3 million people trying to hit that shard for data access, right? So it would, won't it again hog the system is the question. I'll jump on to the next thing. Maybe with the interest of time, I think we have a lot more to cover. Most frequently used data could be separated with metadata, which is not required most of the time. I'm not getting it. Most frequently used data could be separated from the metadata. I'm not sure if this answers the question, Apur. But with the interest of time, I'll try to move on. So there, at least what I have put on, I mean, all the answers could be right and wrong. But what I have put on the slides is sharding based on user ID. That is one of the options, right? Let's say we are like 20 people on the call, and I shard based on that with the user IDs, which will be a unique ID, and we can shard based on that. All right, that is one option. But what will be the issues? Like I said, there will be a non-uniform amount of distribution. Let's say Akshay has 1 million and I have 200 million users only. So, and I don't upload photos at all. All right. So that will cause a non-uniform distribution of storage. All right. So that is again, we get back to square one. All right. It will create a higher latency. And also, if that one shard is down, right? If the shard with my photos are down, it is going to have that unavailability is again going to hit up. All right. So that is one thing which we could try. Another is sharding based on photo ID. I create a unique photo IDs and I shard them based on photo IDs. That is one more possible solution. All right. Then we won't be having anything like on followers or anything, as it's based on photo ID. It will be uniformly based. So these were the two options I had, but thanks for the incoming chats also. We'll move on to the next part, which is to generate newsfeed. right? So this is the crux of the app. So as soon as you enter the app, what you're going to see is the news feed. But how do we even create this news feed, right? We need to populate the latest popular relevant photos. You don't want to see photos which are like 20 days. If someone, a person X, goes to Cannes Film Festival just now, you want to see that photo right now, right away, right? So you need to fetch the top 100, let's say, use photos based on that recency and likeliness, or number of likes, or how much is being shared, things like that. You need a ranking algorithm for you, right? So let's think about this as well. How do we solve this issue? Like that we need to generate 100 photos based on user recency and things like that. What are the different approaches that we can do? Should we have a table called um, user feed, which is going to join many tables, calculate some kind of, use some kind of ranking algorithm and show on the fly to the user the news feed? That would take a lot of time. And we told that latency should be lesser than 200 milliseconds. By that time you join every table and you try to fetch everything into the ranking algorithm, it would take a lot more time. One thing that we could do is we could pre-generate the newsfeed and store it in the table. So whenever the user is asking for the newsfeed, it's already there in the table. All right. So there are different approaches that we can send newsfeed to the users. One is the pull mechanism, wherein the user regularly pulls data whenever they need it. All right. Either we can set an irregular interval or it can be done manually. So whenever new data, but what is the problem with it, right? New data won't be shown unless and until I pull a request. You can visualize this as you have to scroll the screen, right? And it will be showing a loading screen. You will have to manually do that thing for you. And if there is no new data, there will be no, I mean, it will be an empty response if there is no post, no recent post or something like that. So this is one mechanism where we can send the newsfeed to users. Another is the push. Whenever there is a new data, we'll just push it. Okay. But what is the problem with this is, let's say if I'm following many celebrities, I follow Cristiano Ronaldo, I follow I mean celebrities who are very active on social media, right? I follow 50 of them, and they are constantly sending me data. All right, that is again going to now I'm like I'm being pushed all the data whenever I'm getting that data. So it will again hog the system. All right, they can be concurrent things. The best option we can take is the hybrid option. All right, option one in that hybrid version is who have high number of followers, right? Put them to pull model. Let's say I put Cristiano Ronaldo to pull model. He is the highest followed celebrity on Instagram. He won't be having more than that, right? So whenever he wants data, he can just pull that data. Who have less number of followers, put them to push model. Okay, that is one option. And give, or option two is give that push data at regular frequencies, and if the user has a lot of updates, they can pull data whenever they want. Okay, something with, how do we do with data sharding, right? Now we have another problem. To create this news feed, we need to fetch latest photos from all user follows, right? We don't want photos that have to be 20 days ago. So what do we do for that? Let's think. What we can do is we can have the epoch time with the photo ID. Epoch time is nothing but created date time, or whatever you mentioned in the tables, right? We can have that associated to each photo ID. So one part of the photo ID could be the automatic incrementing sequence, and another could be an epoch time. All right. So by that, we can get the latest or more recent photos. So that could be one way, because we sharded using photo ID. That could be one way where we can get a most recently used or recently posted photo. We come almost to the end of the session with cache and load balancing. I think, was it Akshay who was mentioning, or Shubham? I'm not sure. But we were talking about CDNs, right? So CDNs are content delivery networks, which let's say is more geographically distributed servers, right? So let's say just do this comparison. Getting a photo from somewhere more far away, like America or somewhere, would be it would be much faster to get something located in an Indian server itself. So we are calling them as content delivery networks, which we could use for a more distributed users. You can search more on CDNs to get a more knowledge on this. And we have metadata servers to cache hot rows. Right? Caching would be playing a very important role when you have a lot more newsfeed going on, and let's say a celebrity posted a photo and everyone has to see it, right? It would be very a load on the network to get for everyone that photo. So caching would come into picture there. I think Instagram uses something called memcache, which is an in-memory cache, which is an high performance one in a distributed system. And as Suganya mentioned, we can use least recently used to evict the last viewed photos. All right. So these are few pointers for caching, which we can also consider when we are doing a design for a system. So there is something called the Pareto Principle, which was first, I think, termed by an Italian to say that 20% of the, 80% of the wealth which we see in the country is from the 20% of the richest people, 20% of the people. Similarly, it is at least, we can assume that 80% of the traffic which comes to our app is coming from that 20% of intelligent, 20% of active people. All right. So we can try to assume, if we get that numbers, right, 20%, 80%, we can try to estimate how much amount of things we need to cache in hand before. All right. So, so that's it with caching. Quick summary, we had that whole new calculations and things like that. After that, we had component design, redundancy, sharding, newsfeed generation, where we discussed about pull, push, and hybrid. Then we also had something to caching. Reminding you again, we've just scratched the surface of this. There are so many other considerations we'll have to take when we get user usages, and we start to think about cost in such a way, right? There's so many things that would come into mind. So there's so much more to explore as well that we cannot obviously cover in 1.5 hours. So this was all we had. I'll just post these links on the chat so that everyone can look at it. All right. There was some question. What is the best way to keep upskilling on system design and architecture? I think one thing we can all do is to try to read different architectures, online. Online, there's so many resources about system design. Let's say, just pick up one application, let's say Netflix, and try to learn about their architecture, why they have used such an architecture, what are the components used in an architecture, and so on and so forth. Let me try to share one more link to you. This is something I got very recently, but if it's helpful, let's give that a shot. Yeah, it has many system design resources. So maybe we can do that as well. I mean, that's all from my side. It's a continuous process, basically. So it's like it's a never-ending process.
I think uh, to upscale, right? Like I think you should be exposed to more and more of a system design problem. Then only like you will be able to compare different approaches and why they are using it and why not certain things.
Yeah.
So that's the way to like read and upskill on the system design.
Yeah, and also like take topics like let's say sharding, and try to understand the whole thing about sharding. Even if you're not able to apply that in your practical life or in your project, try to learn about it, when to apply sharding and things like that. So that would also be helpful.
Yeah. Now it's around 12:50. We have, I think, we are at the end before 10 minutes. So I have shared the feedback link. I will also float it again. Please add in the feedback because it always helps us to improve, and also in terms of speakers as well as the session content and all that. Feel free to add in any feedback you can think of. It always helps us. I'm floating it again. Okay, so maybe the PPT. So currently,
PPT.
We'll think about it, and then maybe if possible, we can attach it in the meetup page, like if it is possible, where we can attach it.
Sure.
Any other questions? So let's take last 10 minutes or 5 minutes to fill in the feedbacks. Hope everyone is able to access it, right? Like able to add the cards. So let's take 5 to 7 minutes to fill in the feedback. Sharing one more link in the chat for the system design.